Hello viewer, a warm welcome to Elimu TV where you watch and learn. Welcome to our Form 2 Geography Lesson 5. Our subtopic is going to be features resulting from folding. I am your teacher, Madam Abigail Rachel. So preview of the last lesson. In the last lesson, we looked at what is folding. So we said that folding is the bending of rocks due to high pressure from the Earth's crust. We also looked at the different types of fold, and so I said that the different types of fold are asymmetrical fold, symmetrical fold, recumbent fold. So these are some of the folds that we looked at. In case you missed our previous lesson, please tune in the television on Thursday and Friday for a repeat of the lessons that you did not cover up. Today we are going to look at the features resulting from folding and introduction. So I will introduce the lesson by saying that folding leads to the formation of landforms on the Earth's surface. So folding, let's take this as practical. If you fold a paper, you can fold a paper to make a boat. You can fold a paper to make a ship. There are different ways in which you can fold a paper to get something out of it. So through the activities that will take place in folding, it will lead to the formation of the features that will depend mainly on the strength of the compression forces that are going to be involved and the nature of crustal rocks being acted upon. So if there is high pressure, you see that the high pressure, for it to form a fold mountain or any feature resulting from folding, it will depend on the strength of compressional force or even the nature of the crustal rocks. If the crustal rocks are too hard to be folded, you see that there is not going to be any feature that is formed. If the crustal rocks are easy to be folded, then there is a feature that is going to be result out of this action. So the first feature is a fold mountain. You all know what a mountain is. A mountain is more of a hill. It is larger than a hill. It also has a large circumference. You cannot go around a hill. So we look at a fold mountain. So these are some of the highest mountains in the world. An example of a fold mountain is the Atlas in North Africa. We also have the Rocky Mountains in North America. We have the Atlas in North Africa. So let's look at the theories of formation of fold mountains, that is the folds. One, the convectional theory. We looked at the convectional theory in our lesson 3 of this subject, that is Form 2. And we said that in the convectional theory, the molten rocks in the mantle move in a circular motion. Let's take this to be very practical. If you have a wheel, or let's say these big tanks, the metal tanks, it is normally a circular tank. If you climb on that tank and it's rolling down, you'll also likely to move in the direction of this tank that is moving. You know those games that you play, you sit on a tank and you make it roll down the hill. So that is the same case with molten rocks. When they move in a certain motion, these rocks are going to move in the same motion. So the continents floating on it are forced to move horizontally in the same direction. So where a continental plate and an oceanic plate are moving towards each other, we see that the young sedimentary rocks between them will be pushed upwards to form a mountain. That is going to be a fold mountain. The other theory is the plate tectonic theory, and here the fold mountains will be formed when an oceanic plate meets a continental plate. An oceanic plate is formed of oceans, and a continental, this is the Earth's crust. So the heavy oceanic plate will sink beneath the light continental plate. This is very, very true, because if you have something heavy and something light, or let's say let's say water and oil. We see most of the time the oil will sink beneath the water because the oil is heavy than the water. So we have the oceanic plate sinking underneath the continental plate because it's heavy. Then the young sediments at the edge or bottom of the oceans are going to be compressed to form fold mountains. So as a result of this sinking, fold mountains are going to be formed. Let's look at the second feature. This is an escarpment. And an escarpment refers to a cliff or a steep slope or a long cliff. That is, they separate two levels and land surface. So like the famous escarpment of the Great Rift Escarpment. So it occurs when folding takes place on a rock surface, and as a result of unequal compressional forces, this will result to the formation of mountains, but later the middle ground remains unaffected. So when there is a formation of the mountain and the middle ground remains unaffected, there is no effect on the middle ground. An escarpment is likely to be formed, and this is why I have said that it separates two level land surface because the middle ground is unaffected. An example of an escarpment is the Bolivian plateaus of South Africa. We also have the Great Rift Valley of Kenya. It is on your way as you go to the Rift Valley, where we have the viewpoint. If you have not visited that place, make a point of visiting it. We see that escarpments can be formed by 1. Water and wind. And in this water and wind, we see that as the water and wind erode the soft rocks underneath, the hard rocks will tumble down, creating cliffs and escarpments. So as a result of the water and wind through erosion, an escarpment is going to be formed because the rocks will be displaced and they'll probably go to a lower level. As a result, an escarpment is going to be formed. Escarpments can also be formed by faulting. So in faulting, we have the movement of the Earth's top layer or crust along a crack called a fault. So when these crust layers move, as they move along, they may end up cracking, and as a result, a fault may be formed. So it creates escarpments as it moves pieces of the earth around. So when the pieces of the earth's crust are moving around, an escarpment is likely to be formed. Here is an image of an escarpment. This is the Great Rift Valley. So we see that on one edge we have an edge that is very high. This is the light green part of the picture. When you look at the dark green part of the picture, here is where you have the middle land that does not look affected. It is lying low. You can hardly see what lies underneath that place. Our third feature is the rugged terrain. Rugged. What do you understand by something that is rugged? Something that is rugged is not soft. It's somehow rough. And terrain is land. So rugged terrain, that is rough land. So this is where land surface is covered by alternating ridges and valleys. So this land is not smooth. It has its ups and downs. So it is where a hill would form with one steep side and one gentle slope on the opposite side. Let's look at the characteristics of a rugged terrain. The first characteristic, it has an irregular surface. The surface is irregular because it has rocks. One side is flat, another side is steep. The surface here is not regular. The surface is not smooth. It is rocky and steepy. That characteristics, it is rough. So we have an image of a rugged terrain. If you look at this image properly, you are able to see rocks that have no clear definition. They are rough, some are steep, some are just flat. A road in such a place, roads cannot be constructed. That is one disadvantage of a rugged terrain. You cannot construct roads. Even if you want to live in such an area, it is going to take a hard time to build a house. We have come to the end of our lesson today. So I have an assignment for you. And in our assignment, the first assignment I'm going to give you is state the 3 features that result from folding. I have given you 3 features that result from folding. If you remember them, just put it down on a piece of paper behind your geography exercise book. So that is it for today. You can contact us on Facebook, that is Elimu TV, on Twitter at Elimu_KE. Thank you.